Hello, Unit 3 has been on measures of central tendency, and we've had a couple lessons before this. The mean, the median, the mode, the range, you know all that stuff, and the last little part is the mid-range, and then we're going to summarize everything in this lesson. So take out your notes and let's get rolling. So the mid-range, it might be new for you, but it's very easy to calculate. All it is a rough estimate of the middle that's found by adding the highest and lowest value and then dividing by 2. Very easy. You take your high, you take your low, and add them together, divide by 2. Symbol for the mid-range, Mr. Okay. MR stands for mid-range. Can the mid-range be affected much by the outliers? It is very affected. And by the way, outliers are extreme high, extreme low values that are in your data set. I did not say extremely high or extremely low values when it's said to, because that's what an outlier is. It makes our notes shorter, and I'm all about short notes. The last 2 winter seasons, the city in this Minnesota, reported these numbers of water line breaks. That happens in the winter. Find the mid-range. Well, can you pick out the biggest number? Oh yeah, number 8. The smallest number is numero uno. Oh yeah. And all you have to do is add those two together. 8 plus 1, divide by 2, 4.5. That's the mid-range. MR again is mid-range, not Mista. And is this mid-range typical? Is it a typical average? It is, because if you look at this data, you don't have anything that's really high or really low. You don't have extreme values. In other words, there's no outliers. So since the data doesn't contain any extremely high or low values, the mid-range is typical of the average. All right, when is a weighted mean used? When one must find the mean of a data set in which the values are not equally represented, when things are worth more than others. What is the formula for the weighted mean? Oh, hold on to your lug nuts. Here's the symbol for mean. I want you to know that this is the symbol for sum. You should know that. W stands for the weight times the particular data value over the sum of all the W's. So that's what all of this is. So you've got the weight for the data item 1 times the data item, and you add those all up. So the W1 are the weights, and the X1, X2, all the way to Xn are the values. For some reason that kind of messed up. So let's do an example. It is relevant to your life because it's figuring your grade point average. Some people are really into knowing their grade point average, and if I get an A in this class, what's going to happen? So you have that paragraph on your notes, but what you do first is I would put this in a table, like is on the right-hand side, the right-hand column of your notes. These classes have different credits, so they're worth more. So if you get an A in English Comp, it's going to be worth more than an A in PE, because English Comp has 3 credits and PE has 2. Most science classes and hard math classes have higher amount of credits. So the grade, that's your X's, these are your data values, A, C, B, and a D. They're worth different things. You know, people say, I got a 4.0. It's because an A is worth 4 points. A C is worth 2, a B is worth 3, a D is worth 1, F's are 0. So what you do is, your step is to take the weight times the data item. The weight is 3 credits times 4, for that represents your receiving an A. So you take 3 times 4, you get 12. 3 times 2 is going to give you 6. And the next one is going to be 4 times 2, I believe. I can't see it. And then 2 times 1, which is going to give you 2. Then the formula. If you recall, you had to find the sum of all the data items times the weight. So you add those up. Whenever you see the sigma, think sum it up, add them up. So we add them up, you'd get 32. You also need the total number of weight here. So 12. There's 12 possible data points there. When you do the formula, the mean, the weighted mean, this is, and it still looks like the mean is the sum of the weights times the data items, that's 32, over the sum of the weights, which is 12. So we're going to have 32 divided by 12, which is going to be 2.7. So this would represent a 2.7 grade card. Anyway, it's kind of interesting. I always try to keep up with my GPA. We're going to get into the summary portion of this particular part of the chapter, and these things are in pages like 107 to 110 of your book. So if you get tired of writing from the PowerPoint, you can always go into your book and look at these up. So just to summarize, here are these central measures of central tendency: mean, median, mode, and mid-range. You can actually tell how the data is distributed by where these are located in the data. The mean is the sum of the values, and you divide by the total values. You've got two symbols, the fancy M looking thing, and that's if you take the mean of the whole population, and the X with the bar over it, which is just the mean of the sample. Median is in the middle, so it's the middle point of a data array. What's a data array? It's when you put that data in order from high to low, low to high, something like that. You pick out the middle point. If there's an even number of data, then you have data values. You take the middle two and average them. So that's MD for median. Mode is the most frequent data value, and there's no symbol for that. Mid-range is MR, and you're going to be taking the high plus the low and dividing by 2, and that's going to be MR for mid-range. Complete the table listing the properties. So they wanted you to know the properties, for example, for the mean. Again, this is on page 108. I kind of condensed it down a little bit. It uses all the data values to compute. Varies less than the median or the mode when samples are from the same population and the three measures are computed for these samples. It's used in computing other statistics such as variance, which we saw today with the graphing calculator. It's unique and not necessarily one of the data values. So it might be in the data values, it might not. The mean cannot be computed for the data in a frequency distribution that has an open-ended class. Well, that's true. It's open-ended, so it's not ending. And it is affected by extremely high or low values. Those are called outliers. It's affected by outliers and may not be the appropriate average to use in these situations. If you have a person, for example, when I do classes and I have a person that has a 4% average, I might throw them out because perhaps that student hasn't been in attendance and it messes with my whole class average. Let's talk about the median. It's used when one must find the center or middle value of a data set. And the median is also used when you have to determine whether the data values fall into the upper or lower half of the distribution. It's used for open-ended distribution. And the median is less affected by extremely high or low values called outliers. So it's less affected by the outliers. The mode, easiest one of all to calculate. Used when the most typical case is desired, so the one that repeats most often. It's the easiest average to compute, and it can be used when your data is nominal, which means things such as eye color, religion, gender, political affiliation, and so on. It's not always unique. You can have more than one mode, or the mode might not exist altogether. And then we have the mid-range, last but not least, and this is quick and easy. Easy to compute, gives the midpoint, and it's affected by outliers. That's what you need to know in the data set. Now, these averages, or these measures of central tendency, where they fall in your data distribution can help you describe it. So here's the three most important distribution shapes. They're positively skewed, S-K-E-W, no R in there, and negatively skewed. So this one right here is considered positively skewed. Now, I know this seems backwards. I don't know if it does to you, but to me, doesn't it look like the more data is on the left, so you'd say it's left skewed, but it's not. They say positively skewed or right skewed. So here's the description. Most of the data fall to the left of the mean and group at the lower end of the distribution. The tail, that's the little part, is on the right. So if I was trying to remember these for a test, I'd say, where's its tail? If it's on the right, it's right skewed or positively skewed. Now, if I look here, the mode is going to be right there. That's the one that's got the highest frequency. The median would be there, and the mean would be there. So that's how those relate in this data distribution. So if you calculate these, you can tell whether your data is positively skewed or negatively skewed, and so on by how they lie. Mean is to the right of the median, and mode is to the left of the median. So, symmetric, oh, so beautiful. I love symmetry. The description here is that all three of these fall in the same place. The mode, the median, and the mean. Mean, median, and mode, the M's. So the data are evenly distributed on both sides of the mean. When the distribution is unimodal, that means there's only one mode, the mean, median, and mode are the same and are at the center of the distribution. I like that one the best. That's my favorite. Negatively skewed. So where's its tail? Its tail's on the left, so left or negatively skewed. Most of the data is on the right and group at the upper end of the distribution. The tail is on the left. Mean is to the left of the median. So here's your mode. Here's your mean. So where those are, notice that so mean is to the left of the median and the mode is to the right of the median. So that's how you can describe that. And we are finished with section 3.2. I will see you later.